administrator for a small advertising firm, and I'm also one of the SMEs for the North American IPv6 Task Force. Quick history on v6. 1992, the IETF started realizing that we were going to run out of IPv4 addresses at the rate we were going. Bear in mind, this was 12 years ago before NAT came out. And there were some severe technical limitations of IPv4. In 1993, RFC 1550 was created, and in 1995, the next generation internet protocol, IPv6, was chosen for IPv6. Quick comparison between v4 and v6. v4 has 32-bit address space, which makes for 4.3 billion possible IPs. The problem with that is a lot of them are reserved, a lot of them are used for private networks, so you don't actually get the full 4.3 billion. IPv6 has 128-bit address space. It's 3.4 times 10 to the 38 addresses, or 340 undecillion addresses. It basically boils down to 64 billion IPs for every square centimeter on Earth. IPv4, invented 20 some odd years ago. It's got a lot of technical limitations. It's dated. v6 integrates many of the improvements that have been made with v4 and integrates them into the stack. v6 does stateless auto configuration. IPv4, in order to do that normally, you need a DHCP server, although Microsoft and some other companies have been putting in 169.254 addresses when it can't find a DHCP server. When you boot up v6, you basically get an FE80 address, which is also known as a link local. Security in QoS, IPv4, IPsec was actually backported from IPv6. Also, quality of service is an add-on. In v6, you get IPsec, you get encryption, and you get QoS built into the stack. One of the biggest problems that ISPs are having are routing tables. They're getting pretty huge. It's 113,000 on the backbone as of 2003. In v6, the maximum amount of routes you're going to have is 8192 in the default free zone. And here you have a table of, over the years, how the routing table has pretty much skyrocketed. Roaming becomes much easier, especially for cell phones, PDAs, etc., with the use of mobile IPv6 and Anycast. You can basically roam around, get a new tower, you keep the same IP for your cell phone. It reestablishes end-to-end connectivity, which is one of the big things that NAT breaks. A lot of the stuff that you have to kind of tweak NAT to use, for example, voice over IP, peer-to-peer, no longer have to worry about that. What do you need to know about v6? Current connectivity. 6bone is the experimental IPv6 network that was set up in '96. It's about to be depreciated in 2006. IPv6 islands are connected via IPv4 tunnels. You can connect natively if you're lucky enough to have an ISP that actually does native v6. If not, you can use tunnel brokers and other tunneling methods. And the number of IPv6 native v6 networks continues to grow. Your earliest adopters are Asia, Japan, and China. Expect a full conversion by 2005. Korea expects a full conversion by 2008. The U.S. has been very resistive in adopting because we have 70% of the IPv4 addresses, and basically people are saying it's too hard to implement. The DoD has mandated as of October of last year that they expect a full conversion by 2008. NTT Vireo, Speakeasy is working on it, and Hurricane Electric all do native v6, but it depends on what cities you're in. You can also check out the Moon v6 project, which is what the task force is working on along with a bunch of colleges. The addressing is based on hex. Each block consists of 16 bits, and just 2 words of the IPv6 address covers the entire v4 internet. The first word defines the type of address. 3FFE is going to be a 6-bone address. It is experimentally globally routable. It's depreciated in lieu of a 2001 because they're trying to phase out 6-bone. FE80 is a link local address used to get information about your network. ::1 equivalent of localhost, and then : listen on all interfaces. EUI64 is the extended unique identifier. It's based on your MAC address. This is actually the last 64 bits of your IPv6 address. Basically, you take your MAC address and throw an FFFE in the middle of it. Duplicate address translation, and no, I'm not referring to Joe Klein or Dad. Ensures machines do not get the same address when booting and using auto configuration. Link local addresses are generated and they're tentative, and then the node goes out and checks to make sure that no other computer on the network has that same address. If a dupe is found, the auto configuration stops, and you got to go in and configure it manually. Okay, that's weird. Using the MAC as part of the IP is considered a privacy issue, and it's not really addressed in RFC 2373. But RFC 3041 describes a randomly generated interface identifier that changes over time to provide a level of anonymity. Sorry. 2001 production globally routable. 2002 is used for 64 tunneling. FEC0, which is site local address, basically equivalent to your 192.168 or your 10 dot addresses. These are currently being depreciated in lieu of FC00/7. FFO1, FFO2, and FFO5 are for multicast. Operating system support. FreeBSD, OpenBSD, NetBSD, OSX, BSDI, all come with the Kami stack, which is arguably the best IPv6 stack out there. It's available from www.kami.net, and IPv6 is enabled by default in these operating systems. Kernel 2.4 for Linux has got a pretty buggy v6 implementation. It works, don't get me wrong, but it can be augmented with patches from the Usagi project, and Kernel 2.6 actually has those patches from Usagi built into it by default. Solaris 8.x and above, native support. Novell NetWare 6 and above, native support. Load the BSD sock.nlm. So I wonder where they got their stack from. 98 and ME. Quite honestly, if you're doing v6, I wouldn't be using these operating systems anyway. Although you can get third-party patches from Hitachi and Trumpet. NT4 had a very, very early beta v6 stack. 2000, not quite as bad of a beta, but it's still pretty nasty. XP and Win2K3, the IPv6 stacks are built in. All you do is IPv6 install. And then from there, you can use NetSH to control the IPv6 from the command line. Your current North American IPv6 providers, NTT Vireo, Freenet 6, and Hurricane Electric. NTT Vireo supplies tunneling services to its customers that aren't in the major cities where they can provide the native v6. Hurricane Electric and Freenet 6 are open tunneling servers. Anyone with an IPv4 address can tunnel v6. You can go to tunnelbroker.net for Hurricane Electric, and that's only if you have a static v4 IP. and then you can use freenet6.net for a dynamic v4 IP. There's tunnel brokers all over the world, and many of them only require online registration. Tunneling and transitioning mechanisms, you have ISOTAP, tunnel brokers, 6-to-4, Teredo and Silk Road, NatPT, bumping the stack or bumping the API, dual stack transitioning mechanism, tunnel setup protocol, and many of these use IPv4 as the transport. ISOTAP is used mostly for v6 connectivity between hosts on a LAN, WAN, or VLAN. Requires a 6-to-4 gateway for packets to actually leave the local LAN. Can be used for an IPv6 NAT, although it's not recommended. IPv6, the IPv6 address includes the IPv4 address in it. 6-to-4 via tunnel broker. This is probably one of the more popular ways to connect if you don't have native. Requires IP protocol type 41. Doesn't work with NATed v4 hosts unless you do some really nasty hacking on your NAT. Most tunnel brokers will give you a /48 or a /64 for the rest of your network. Do I need to bother reading these numbers? This is for one network. I somehow doubt you're going to have that many machines. They're very easy to set up and change. The only thing is they're also frequently used as an attack vector because most sysadmins would look at a router advertisement and go, so what? Meanwhile, 3 or 4 of their machines behind that firewall happen to have v6 addresses on them, and somebody's attacking them natively. 6x.net has a 64 proxy that only shows the IPv6 source address. 6-to-4 via auto tunneling. This is very easy to set up. Convert your v4 address to hex and put a 2002 in front of it. That gives you a /48 for the rest of your network. Set the default route for IPv6 traffic to 192.88.99.1, which is an Anycast or magic address. It uses BGP to find the nearest 6-to-4 router and connect you to v6. Security is questionable. There's very little choice on where your traffic is routed if you happen to use that Anycast address as your default route. XP Service Pack 1, if you do the IPv6 install and you have an external address, this will do this by default. It's not included with OpenBSD because it's considered a security risk. One of my favorites, Teredo. Bear in mind, Microsoft came up with this beautiful protocol. IPv6 tunneling over UDP. What a great way to slice through a firewall. Uses port 3544 by default. The ports can be changed, I don't know, 53, 500. Make it look like DNS or IKE traffic. Microsoft and Linux and FreeBSD implementations are out there, and I need to correct this. Windows XP Service Pack 1 and 2 have a client. FreeBSD and Linux also both have Linux, Teredo servers, relays, and clients. Could very easily be used as an attack vector, considering most people don't pay attention to their UDP traffic, and they're never locked out of the firewall. I'm getting to that. This is considered a last-ditch IPv6 tunneling mechanism. The Windows client will check to make sure that there's no other way for it to connect to v6 before it does this. The draft calls for the use of 3FFE:831F/32 only. It doesn't allow for tunneling through restricted NATs. This is one of the other ones that hasn't been too widely deployed. It's only in draft right now, and there are no clients or servers. Silk Road uses UDP again. The draft calls for 5188. if anybody does actually write something for it, again, it could probably pretty easily be used as an attack vector. Allows for any address range. Like I said, it's a fairly new draft. And this acts more like a UDP-based tunnel broker. NATPT is Network Address Translation, Protocol Translation. The RFC is 2766. IPv6 host send requests to a dual stack gateway. Gateway decides if the remote is IPv4 or IPv6. Stamps a header on it if it's a v4 target. When it gets the packet back, it takes the stamp back out, sends it back to the IPv6 host. Cisco probably has the only production quality implementation. There's a lot of betas out there you can try out for Linux or BSD. The technology is kind of similar to using IPX SPX on your internal network and then having an IPv4 gateway route it to the internet. Bumping the stack, bumping the API. Your RFC numbers are up here. It's used on dual stack hosts to proxy programs. Security is questionable because you actually got to go in and basically hack the program. XP in 2003 include one called port proxy. Dual stack transitioning mechanism. It's based on dynamic IPv4 over IPv6 tunnels. Does a temporary assignment of a global IPv4 address to an IPv6 host. Allows IPv4 only apps to run in a v6 environment. Requires a DSTM gateway and server. It's multi-platform and minimizes the need for globally routable IPv4 addresses. Transport Relay Translator works as a DNS proxy. The TRT server takes the IPv4 address and converts it to IPv6 and then sends it out. There's BSD and Linux implementations for it. It's based on TOTD and FAITD on the BSD side and PTRTD on the Linux side. And the RFC for that is 3142. This one actually just came out in June, and Freenet 6 is using the hell out of it. It's Tunnel Setup Protocol. Now what this does is it automatically decides whether you have an external or a NATed address and sets up your tunnel accordingly. It uses IP protocol 41 if the v4 address is public, and then it uses UDP tunneling if it's NATed. Freenet 6 is currently the only provider, being that they wrote the draft for it, and the draft is available there. Router advertising. This allows your IPv6 border router to broadcast its existence to its clients. It advertises to the clients their IPv6 prefixes and the default route. It differs from DHCP because it can only broadcast the default route and the prefixes. It can't do things like WINS, DNS, etc. The router advertiser server is available in most IPv6 capable OSs. DHCP v6 combines the functionality of a router advertiser and DHCP v4. It's currently in alpha stages in most implementations, except Cisco again. Provides prefix delegation and facilitates the distribution of IPs, default routes, DNS, WIN servers, blah, 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 blah. Basically anything you can do in DHCP v4. Firewalling for v6, IPFW and PF for BSD, IP6 tables for Linux. And there's a built-in firewall in Windows XP. It's controlled by NetSH. 2K3 does not have an IPv6 firewall at all. What the heck did I mean by that? Sorry, I went through this while I was drunk last night. And yeah. Windows XP, before the advanced networking pack, did not have an IPv6 capable firewall. What you have after that is actually an IPv6 firewall service that you can stop. For all the consumer firewall applications, Zone Alarm, basically anyone that I've tried, Zone Alarm, Black Ice, Curio, they might pick up 6-to-4 traffic, but they do not defend against native v6 traffic, which is scary. I actually wrote a little telnet daemon type program and was listening on v6 only. Zone alarm pops up, says, do you wish to allow this program to access the internet? No, remember this setting. And I telnetted right in. As far as security goes, block UDP traffic if you're not using it. Also IP type 41. Scan for unauthorized router advertisements. If you're on a v4 only network and you're getting router advertisements, odds are you've been owned. As always, if you're not using the protocol, don't use it or don't enable it. IPv6 DNS, v4 uses the A record. So if I wanted to point Hacksonville.org to a RFC 1918 address, I don't know why I'd want to do that, but IPv6 uses a quad A record. And again, why I'd want to point that to a site local, I don't know, but IPv6 applications, a lot of times if you have the source code for v4, it's somewhat, well, it's probably somewhat of a pain in the ass to get it ported to v6, but it depends on how complex the program is, of course. IPv4 applications can be proxied. If you're actually writing applications, make sure they can handle a colon in the address. And any apps that are written pretty much in the next 4 or 5 years should be able to support both. Some sample code. IPv4 only uses IPv4 specific libraries and system calls. The main things you want to pay attention to here are the AFINet calls. AFINet is v4 only. So if you're writing a program for dual stack, what you really want to do is let the DNS decide for you whether it's going to be talking to v4 or v6. So if you take a look here at your interface family, you're doing protocol family unspecified, which means I don't care if it's v4 or v6, just give me the address. Say if you wanted to change the Apache config for v6, Apache 2.0 all the way up to current will actually listen on v6 natively. All you got to do is tell it to listen on : on either 80 or 443 or whatever other port you happen to want to run Apache on. SSHD, it's about the same thing. Port 22, protocol 2, that's highly recommended. Just tell it the listen address is : or if you want it to listen on both v4 and v6, : and then another line with the listen address of 0.0.0.0. And here we have the 12 steps for overcoming NAT addiction. And y'all let me know when you're done. And yes, I ripped this straight off of AA. Cool. I think that's a fair assumption. All right, the next slides are just links, so we got any questions? Shoot. Right. The thing is, they pretty much every business or every home network, quote unquote, is going to get a /64. Endpoints are going to get /64s. No. Yes. Right. The internet too, from what I understand, I haven't done a whole lot of reading into it, and I suppose I should, but the internet too is basically they're running fiber, a new fiber backbone between all the colleges, um, and I'm pretty sure it's protocol independent. Yeah, it's just a big fat pipe. Yeah, because actually UNF, because I'm from Jacksonville, UNF is also getting it, but but a friend of mine that is actually going to UNF said basically it's just fiber. Um, there's actually a few different ways to look at that. Um, First of all, they don't have the adapters to do it yet, but IPv6 supports what's called a jumbogram. One packet can be 4 gigabytes. That's the thing, though. The NTUs don't support it currently. Right, right. So once they do come up with the hardware, right. Yes, sir. No, you don't. Because you think about it, the ports are layer 4, and admittedly, IPv6 is going to be layer 3 and layer 4, but you're still stuck with 65,535 ports. In the slide where I had the yeah, yeah, and actually that's you also use that if you're typing in, say, an IPv6 address into Mozilla or Internet Explorer. Um, you use the brackets around the address after the HTTP:// It actually depends on the application. Like, well, like for example, I'm trying to figure out a way around this, but I'm trying to run 2 versions of Apache on my Linux box, and have my 1.3, which is my, that's the one I use for, my websites, my webmail, etc., etc. And I'm also trying to get Apache 2 running at the same time, listening on v6 only, and it won't give me the port. Uh, if you happen to know the IP address of the box you're attacking, sure, no problem. But good luck spanning a /64 anytime soon. Um, Shoot, it's actually in that paper. But right now, with the technology that we have, and actually Dan Kaminsky's been a big part of this, um, we're basically able to scan our entire internet in about 10 hours. Now, if you do that math and put it over a 128-bit network, it's going to take trillions of years to do it. Well, yeah, but then again, the V4 internet isn't full either. Odds are they've taken the reserve networks, dropped them off. They've taken, the 10 dot and 192.168 dot, dropped those off, and they're only scanning the live. Run that by me again. Right. Right. Okay. 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 I don't see why not. I've never actually tried that, but I don't see why not. But do you really want to type out something that long? I have this bad habit when I'm drunk too of registering strange domain names. Yeah, actually, thebrotherscline.com is dedicated to Joe Klein over here. Uh, there's quite a few of us who are calling him Dad now, hence a reference to duplicate address uh, detection and Joe Klein being Dad. Yes. I'm actually working on another presentation for this. Um, Basically, the main thing that you should be paying attention to right now, um, run an ether scan on your network. I'd say, once, twice a week, and make sure there's no router solicitations and router advertisements, because at that point you're seeing V6 traffic. Yes. What's that? Okay, Joe's informed me that Snort can also do it. Hmm. Yeah, because actually, well, all right. First of all, it depends on whether you're on a switched or a hub network, or whether you're plugged into the management port on the switch. But Etherreal does a lot of layer 2 stuff. So yeah, it'll see router advertisements, even if you don't have a V6 address on your box. Anybody else? Shoot. Uh, because of the spec and because of the EUI 64, the last 64 bits of your address for the router advertisers, they basically have to give you a /64 because of the EUI. Yes. Why don't they? What was the FFFE? Yeah. Well, your MAC address is only 48 bits, and they need to extend it out to 64. I didn't write the RFCs. I just follow them. Well, when that happens, then they won't need the FFFE, and it'll just ignore it. Yes. Yes, sir. Well, the thing is, they are completely separate protocols. Say, for example, you're running IPX SPX and IPv4 on the same box. Those two protocols aren't going to see each other. And the same thing with V4 and V6. Um, okay, if you're running an IRC server on IPv6, IPv4 hosts, without doing some fancy footwork, are not even going to be able to connect to it. Well, that's part of IPsec. Okay. Right. Uh-huh. The thing is, they're not going to see a 6-bone route. Hmm? Um, okay, is the IRC server dual stacked, or is... Okay, an IPv4 client. Okay. Okay. No, it just uses its v4 address that it has to get the tunnel in the first place. So your v4 clients are going to come in via the v4 address that Earthlink gave them, and then your v6 clients are going to come in through the tunnel via, FreeNet 6 or Hurricane Electric or whoever gave them the v6 tunnel capabilities. If your provider will only give you a v4 address, then your v4 clients are only going to hit that v4 address. The predictions have been 10 to 15 years. He's right. It'll never be all the way. You're always going to have legacy systems, but at that point you're going to be using that PT or some kind of transitioning mechanism to get the legacy 4 boxes to talk to the rest of the v6 network. Yes. The way I went about it, I started off with FreeNet 6 back when they were doing 6-bone addresses, just to get on to 6-bone, just to play around with it. From there, I went to Hurricane Electric because they were using 2001, the non-depreciated addresses. But they only give you a /64 instead of FreeNet 6, who gives you a /48. It actually helps with the subnetting. Yeah. Well, a /48 will give you 65,535 /64 networks. So, I can have these two machines on one subnet on a 64, these two machines on another subnet on a 64, and I can play with the routing and all that. I've since gone back to FreeNet 6 because their new TSP rocks. I mean, you can connect via UDP if you're behind a NAT. If you're straight on the internet, you can connect via Protocol 41. It's login and username based, so if you have a dynamic v4 IP, you can still keep the same v6 addresses. No, the DHCP is going to be stateful. But I might have hosed a slide. Uh-huh. This right. The the router advertiser and the FE80 address that you get on boot are going to be stateless. And then DHCP v6 is going to be the stateful. Anybody else? Well, good. I'm going to go smoke. Y'all have a nice day.